Okay, good morning students. I am Chatterjee. I came back with part 6 today, and today we will deal with the set operations and the set laws in this chapter. So let us see what are the set operations. Now you know that we have got the very basic mathematical operations like division, multiplication, then addition, subtraction. These are the basic mathematical operations. Also set follows some kind of operation. Okay, set also follows some kind of operation, so that also we need to consider for adding or subtracting the sets. The first operation we consider as union. Union, also written as U. We sometimes replace union by or, and a sign may be like this. So these are all signs of same meaning. Okay. So the first operation you can say union. Now union, actually what is union? We don't have addition in set. So that means why we don't have addition in set? Because you know, say what will happen if I have say 3 elements 2, 3, 4 and try to add something like 3, 5, 7. So addition will cause the it will bring us kind of duplicate 3 into the system. That means it will be something like 2, 3, 3. So 4, 5, 7, it will be something like this. That means this 3 will be duplicated, and that is actually not true, or that we do not consider in case of set, you know. So addition we don't consider. So this 3 has to be replaced. These 2 3s, instead of these 2 3s we write only 1 3 in the set. So that operation means we are not adding, because you know addition means what? It's if you write x plus 2x, it's supposed to give you 3x. That means it's not like that you take only one common x from these two and something like that. So addition we don't consider in case of sets. Instead we bring union. So this is when we consider element once, it's called as union. Let's see what union is. Say we write a set like A equals to say 2, 3, 4, and say we write a B equals to something like 3, 4, 5, 7. The same example which I wrote. So let us draw some circles. So these are known as Venn diagrams. So Venn diagrams are what? Venn diagrams are easy figures just to illustrate the sets, so that it becomes pictorially very easy for us. So A, B. So if I put 2 and see 3, 4 is 3, 4 are the elements which are common, okay, between two sets. So I write 3, 4 over here because the set A and set B, they have something in common. So this is 2, 3, 4 and this set B is 3, 4, 5, 7. Hope you understood this. So this is 2, 3, 4 and this is 3, 4, 5, 7. So now here what to write in place of union? So by union we write A union B, where we write 2, 3, 4, 5, 7. That means every element to be considered once. So algebraically we say that the element is either present in A or it's present in B. That means if we try to write algebraically, that if we write if X belongs to A union B, it implies that X belongs to A, X belongs to A, or X belongs to B. So this is the meaning of this union. That means X belongs to A or X belongs to B. So that we mean by union. Next operation we will do. So before going to next operation, if we want to shade what is A union B, it will be this shaded area. Okay, so this is A union B. So let us move to next operation. So what I'll do, I'll use the same example. So I write here intersection. Intersection is denoted as something like this, inverted U, or you can say and, or like this. So here what we mean, this elements which are present in A and B. A and B means it should be present in A and also in B. That means they are the common elements. So if I quickly draw this, I get 3 and 4 which are there in the common area between A and B. So the same example I have taken 2, 3, 4 and 3, 4, 5, 7. So here A intersection B will be the common elements. That means 3 and 4 only. Okay, so if I want to write it in terms of these algebraic ways, so what I shall write? Say if Y belongs to A intersection B, that means this intersection has to be replaced by AND. Look at here, I have written AND. That means it implies that Y is present in A and it is also present in B. So this is the meaning of this intersection. So this is how we get operations, union and intersection. Apart from this, we also have subtraction. Subtraction of sets. So that I will show you. Again we take the same example. So subtraction, or you can say difference, set difference between two sets. So I will take the same example and this will be something like A minus B. So let us draw the same thing. Now what is subtraction? Subtraction means when you subtract A from B or B from A. So I first do A minus B, that is I try to subtract B from A. So look at it, what happens? The thing which happens is B is totally erased. See, I am erasing out B. Why so? Because I have subtracted B from A. So it looks like a moon crescent, right? So that is A minus B. A minus B is left with only one element, that is 2. A minus B, it's actually only one element is there, that is 2. Okay. That means when you subtract, B has to be entirely deleted. Although it's containing few elements of A, B shall be totally taken out. So whatever left in A, that will be the value for A minus B. Okay. Now let us make it more clear. I rewrite the thing. I will try to find out B minus A. So when I do a B minus A, that means A has to be totally removed from this thing. So if A is removed, just see what happens. I will remove A. That means I try to delete A from this. Look at it. What you get? So you get only 5 and 7. That means this part of the crescent where you get 5 and 7. Could you follow? So A minus B and B minus A are actually done like this. Okay, I will try to recreate the diagram again and show you something else. See, I have redrawn the diagram and I want to depict all these things algebraically. So I take if x belongs to A minus B. If x belongs to A minus B, that means what? That means it means that it is not in B but it is in A. It is not in B, it is only in A. So it means, it implies that x belongs to A and x does not belongs to B. Look at it. But both the statements, both of these are true. Both the statements are true. So you have to connect them by AND. You have to connect them by AND. That means x belongs to A, that is also true. X does not belongs to B, that is also true. Similarly, here if you write if y belongs to B minus A, it has to be something like y belongs to B and y does not belongs to A. Does not belongs to means it's not in A. So it should be connected by AND. Okay. So now a little modification to this. I'll show you the symmetric difference. So symmetric difference is actually the union of A minus B and B minus A. So what I do, I write like this. It's a symmetric difference that's given by a delta thing. So A del B. This means what? This is called as what? I don't have space. I don't want to erase this also so that you can understand. This is another operation. Please understand. It's called symmetric difference. Symmetric difference between two sets. Okay. It's called symmetric difference between two sets. So it will be something like A minus B when united with B minus A. Okay. A minus B when united with B minus A, you get all the elements. That means what you get? 2 you get 2, you get and 5 and 7. So symmetric difference means it's actually you have to exclude the middle part and shade everything. So that is what we mean by symmetric difference. So that is 257. So that is actually the meaning of A delta B. Okay. So if we try to show up the symmetric difference by 257, so this will be the thing. Another way also we can show up, I'll erase this and show you. So look at it, the symmetric difference, whatever we wrote like this, A delta B, that means this line, that means only the middle part is excluded. So what we can do, we can also take out the middle part, which is A intersection B from A union B. So you know A union B is everything, that means 2, 3, 4, 5, 7. So when you take out A intersection B, that means 3 and 4, so you get only 2, 5, 7. So that is also, you see, the same symmetric difference between two sets. So this is all regarding the set theories, set operations. So we have got four operations mainly: union, intersection, then difference and symmetric difference. So now we will proceed with the set laws. So I have written set laws over here. So we will try to learn few of the set laws. So let us see how many set laws we get. So number one, we get idempotent law. So this is idempotent law. This is a set law. So what we do here, we try to unite between the same set. Okay. So if you unite A with A, you will get A only, because we know the set's elements are not duplicated. That means it will give you the same set A. If, for example, if 2, 3, 4, this is set A, and again another set A is united, so you basically get 2, 3, 4. So this is idempotent law. That's the union between the same sets and intersection between the same sets. A intersection A. This is, if you try to do A intersection A, then also you get A. Because if you try to take out the common part between A and A, you will get the same elements. So this is all about idempotent law. Next is identity law. The next is the identity law. So here, in case of the identity law, what we find? We find union of A with something that will also give you A, but it's actually not the previous idempotent law. That means we already did that union between the same sets will give you A, but here we are not going to unite the same set A but a different thing. So what could be that? So if you look at it, if you unite a null set with it, you will get A. So if you unite a null set, means it will have no elements, you will get A. So you can write two small points over here. Maybe I have omitted when I taught you the subset parts or null set. So here you write null set is a subset of every set. So null set is a subset of every set. That means here better this thing you will get in power set. Since there you saw that null set is coming in every power set. So null set is a subset of every set. These are points I am giving you. You can just add in your copy for reference. And next you write every set is a subset of itself. Every set is a subset of itself. So these are the 2 points I might have missed in while I made the subset videos. So please write down. This will try to make you understand that A union phi will give you A. Now similarly I have to intersect something that will give you A. Now what is that? Now what is that? If I intersection of another set will give you A, means obviously what? That will be universal set, because if you take say 2, 3, 4 are there, here 1, 5, 6, 9 are there. So obviously this outside part will be what? Outside part is a dashed and this part is a. The outside part is a dashed and this part is a. So when you, and whole of the part, that means 1 2 3 4 5 6 9, everything will be u. So if you basically take out the intersection, you get same a. Okay, so if you take out the intersection with universal set, you get a. So this is the identity law. Now number 3. Number 3 is commutative law. Number 3 is commutative law. Commutative law is actually, it's union between two different sets and you change the order. You know what the commutativity means. So commutativity, A union B will be equals to B union A. Same thing. So here also another law we write, that is A intersection B will be equal to B intersection A. I can erase this part, that will be good for us, making space a little. It's B, I write A intersection B, sorry, B intersection A. So it means the same thing. Okay. Now you know few of the operations are commutative, like say 3 plus 5 is equal to 5 plus 3. That means if you change their order, nothing will happen. Or 3 into 5 and 5 into 3. But when you do 3 minus 5, you cannot write 5 minus 3. They are not equal. That means here what we get? Addition or multiplication, these are commutative. Okay. But subtraction is not commutative. If you change their order, it's not working. Or if you write 3 divided by 5 and 5 divided by 3, this is not going to work. This is obviously not true. So for division and subtraction, the commutativity does not work. Like think over here, you can say that commutativity works for union and intersection over here. Next law, associative law. Let's see associative law over here. Associative law depicts some kind of association between sets. Okay. Associative law depicts some kind of association within sets. Association, the word association, you can say it means groups. Okay. So we basically group the elements. So how you do it? So say I have few numbers like this, 3 plus 5 plus 6. So if you do a 3 plus 5 first and add a 6 with it, okay, then also you will get 8 plus 6, 14. Or if you do this 5 plus 6 first, then also you are going to get 3 plus 11, 14. That means you have to associate. You have to associate any two elements with that kind of operation and it works. Okay. So it doesn't work for any kind of situation. Yes. So we write like this. If I write A union B union C, I can take B union C first and then I can associate with A. Just I have shown you this example. Or I can do A union B first and then I can associate with C. So it means the same thing. So this is basically the associative law. Now I will show you the same thing by intersection. So A intersection, you can take different examples for sets A, B, C and try it. You will get the same result. So these are the set laws, they will work. Okay, so basically if I do this operation first, A intersection B and associate with C, you will get the same result. So this is all about the associative law. Okay, now the next law. Number 5, we see we have got distributive law. By the way, we have totally 8 set laws. That's why I wrote an 8 over there. Always remember, you have got 8 set laws. Now distributive law is what? Distributive law is something like this. Say we do 3 into 5 plus or 3 into x plus y. What we do? So 3 multiplication x plus y, we do a 3x plus 3y. So that means we distribute this addition sign. We distribute this addition sign over multiplication. Okay, we distribute this addition sign over or on multiplication. This is very important. Look at it. You have to understand that which sign is getting distributed. Look at it, plus. So who is distributing? Plus is distributing. What it is distributing? It is distributing multiplication. So that means multiplications are separated on two sides with the help of plus in between. So distribution of multiplication over addition. So we do this thing. I'll tell you, I'll give you the same example. And in another word, I'll say that addition on multiplication. So if I write A union B intersection C. Okay, but this is not going to work always. See, if I write like this, something like xy. Can we write like this? 3 plus x into 3 plus y. So algebraically this is not true. But still we get Boolean algebra sometimes where it is true. So that is a different issue. But look at it, it's not always true. So we have to take care where it is happening and where it is not. So let us learn. A union B intersection C, we are distributing union A union B, then A union C. We are distributing union over intersection. So distribution of union over intersection. Distribution of union over intersection. So intersection is coming in the middle. Now the next part will be A intersection B union C. So that we write A intersection B and A intersection C and union in the middle. Union in the middle. That means this is the distribution of intersection over union. So in exam sometimes they will give you, question will come like that prove the law of distribution where, or prove the distributive law where union gets distributed over intersection. Union where union gets distributed over intersection. That means you have to do the first thing. That means union get distributed over intersection. So you have to understand what they are, what the statement is actually meaning. So be very careful about these statements, distribution of union over intersection or distribution of intersection over union. Okay. So this is the distributive law. Number 6 is most important. Number 6 is very important, and that is the De Morgan's law. It's the De Morgan's law. This De Morgan's law you will need at many places, maybe in class 12 also in some related topics. So this is it. So De Morgan's law, there are two De Morgan's law. I'll draw a Venn diagram maybe in the next class or this part to show you up a little bit of the proofs of this. So A union B whole dashed. A union B whole dashed is something like A dash intersection B dashed. So what you can do as of now, you can draw simple Venn diagrams, you can take elements, you can take some sets and try to prove this. Okay, that A union whole dashed means what? It's a complement. We learned that means if you draw A union B, it's outside A union B. And the second law is something like A intersection B whole dashed becomes A dashed union B dashed. Just look at it. It means only the sign gets reversed in two places. So these are De Morgan's law to be proved by Venn diagram we will do, or you can use algebraic laws to prove this also. Those things also we can do. Number 7. Number 7, we can use the complementary law. Complementary law. I am not showing this because when this De Morgan's law, because I need everything. I want to jot everything in one page. Okay. Now I have to erase few parts if I want to show this. So I'll probably show this thing in the next video. So complementary law is what? Complementary law means if you try to get A dashed, that means not A. Similarly, what we get here, we get something like U dashed. U dashed means outside U. Outside U is what? Outside U is nothing, so null. Or if you try to get null dashed, you get U. So these are the kind of complementary laws we have. So you can write something like, say, A union A dashed. A union A dashed is what? It will be U. So you can mark it 1. That means A united with not A will give you everything. And you can also write something like A intersection A dashed. That means A and not A. What thing they will have common? Nothing they will be having common in between them. Because A intersection A dashed is phi. That means not. It's null. It's null. Nothing is there. So these are the complementary law, and last is the involution law. Involution law. So this is the last set law which we learn. That is, this is very easy. Negative, negative, positive. Things like that. A dashed whole dashed will be A. There is only one law. In every other laws, all of the other things we get 2 laws each. So here we get only one. So A dashed whole dashed, that means complement of A complement is A. So that is the involution law. In the next part, I'll try to prove a few of these set laws. So we have completed the set operations, union, intersection, difference and symmetric difference, then the 8 set laws. Please copy it down in your registers or notebook and try to revise. Thank you for the day.